Hello there, and welcome. I'm glad you made it. Maybe today felt long. Maybe your mind is still turning when all you want is to rest. Or maybe you're the kind of person who finds peace not in silence, but in distant suns, in the slow and elegant dance of the cosmos, unfolding far beyond our little world. Whatever brought you here, I hope you'll let this moment be enough. You don't need to do anything now. You don't need to understand every word or follow every fact. You've arrived, and that's more than enough. So lie back, get comfortable, and let your thoughts stretch out like starlight. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Tonight, we aren't just stargazing. This isn't astronomy class, and there's no quiz at the end. This is something softer, stranger, a quiet unraveling of the universe's most wondrous truths, one gentle breath at a time. Tonight, we'll travel through 100 of them, not all at once, not in any rush. Each one a step deeper into the mystery. Not answers, exactly, but invitations. The kind you don't have to accept right away. You can just float beside them. The cosmos is old, older than your thoughts can hold, older than every story ever whispered by firelight or printed in any book. Over 13.8 billion years have passed since time itself began, since the fabric of space stretched out from an unimaginably small beginning, and yet it's still growing. The universe is not static. It expands, it ripples, it remembers. There is no edge, no center, no still point where it all began. Only motion, only unfolding. From the smallest particles to the largest galactic clusters, everything you'll hear tonight is part of that motion. Gravity, light, atoms, silence. All moving, all shaping, all flowing forward like a river with no banks. You are floating in it now. The same way your planet orbits the sun, and the sun spirals through the galaxy, and the galaxy drifts through the dark on currents no eye can see. The universe is not cold, not really. It has temperatures, of course. Places so hot they could vaporize atoms, and regions so cold they freeze light into silence. But that isn't what I mean. What I mean is, it's not empty of meaning. It isn't sterile. It isn't cruel. The cosmos is a mosaic. A vast, breathing patchwork of creation and decay, of order and collapse, of chaos that somehow arranges itself into spiral arms and planetary rings and particles with just enough charge to one day become skin, bone, breath. Some people think space is a void, that the stars are just distant dots in black nothing. But if you've ever looked up on a moonless night, far from the noise of cities, you know better. You've seen the river of light. You've felt the hush. You've sensed something bigger than comprehension. A cathedral with no roof. A story that's been telling itself since long before there were ears to hear it. And in that story, you exist. Not separate from it, but inside it. A character made of atoms that once burned in stars. A mind that formed from a planet, that formed from dust, that formed from explosions that shook galaxies. You are a continuation of cosmic processes, not an interruption of them. The same laws that bend starlight also shape your thoughts. The same elements that form a supernova echo through your bloodstream every second. You are not an observer of the universe. You are the universe, momentarily aware of itself. Tonight, as we drift together into this quiet sea of knowledge, let your thoughts uncoil. There's no pressure to remember, no pressure to understand. You don't need to solve anything. You only need to listen, or not. Let the words wash over you like gentle waves. Let each truth arrive softly, then fade. We'll begin soon with stars, with the first light, with the strange beginning of everything. But not yet. For now, feel the gravity in your spine, the way your body presses into the bed, the weight of your limbs growing heavier, slower. Imagine the cosmos stretching beyond your ceiling, beyond the clouds, beyond the sky you know. Imagine galaxies like islands in a vast black ocean, each one glowing with hundreds of billions of suns. Imagine the silence between them. Imagine drifting there. You don't need to leave your room. You're already traveling. Your thoughts are light. Your breath is motion. The universe is not somewhere else. It's here, it's now, and it's always been. Close your eyes if they haven't already. Let go of the day. Let go of needing to be anywhere or anyone else. You've arrived in the infinite, and it's glad you're here. It didn't begin with a bang. Not the way you're probably imagining. No fireball bursting outward through empty space. No roar echoing through a void. There was no sound, because there was no air. No space, because space hadn't unfolded yet. There was no where for anything to explode into. No past to come from, no future to fall toward. Just everything. Absolutely everything. Compressed into a single, infinitesimal point, dense beyond comprehension, hotter than any fire, brighter than any light, yet with nowhere to shine. And then it expanded, not like a bomb, but like the fabric of space itself stretching open. Within the first sliver of a second, the universe swelled from subatomic smallness to something far larger, not because matter was flying outward, but because space itself was growing, doubling, redoubling, racing forward in a silent bloom. Time began ticking, energy crystallized into particles, forces separated, and began sculpting everything that would ever exist. There were no stars yet, no galaxies, no light in the way we understand it. Only a dense, roiling fog of particles and radiation pressed together so tightly that nothing could move freely. Every inch of space was hotter than the core of any star you know. Photons ricocheted endlessly, unable to travel far before colliding again. The universe was bright, but not transparent, glowing, but blind, and yet it was already changing. As expansion continued, the temperature began to fall, not quickly, but relentlessly. The universe cooled enough for protons and neutrons to form atomic nuclei. A little more cooling, and electrons could settle into place, orbiting those nuclei and creating the first atoms, mostly hydrogen, a little helium, and traces of lithium. No carbon, no oxygen, no iron, no life. Just the barest alphabet of matter, drifting through a universe still too young for complexity. Eventually, about 380 years after it all began, things grew calm enough for light to break free. That moment, quiet, unremarkable to anything that might have been watching, is etched across the sky even now. The photons released then have been traveling ever since, stretching into microwaves as the universe expanded. That ancient glow is still around you, passing through your body every second, humming gently as the cosmic microwave background. It is the whisper of the beginning, a fossil made of light. You can't see it with your eyes. But if you tune a television to static, a tiny fraction of that hiss comes from the afterglow of the Big Bang. Not a metaphor, not poetry. Actual light from the first time the universe became transparent, scattered across space, still echoing in every direction. The oldest light you will ever encounter, and the most honest. Back then, the cosmos had no stars to punctuate its darkness, no planets spinning in orbits, no galaxies twisting like leaves caught in gravity's slow whirlpool. It was quiet, it was vast, but it was not empty. It was pregnant with possibility. Gravity began its patient work. Tiny fluctuations in density, The unevenness left behind by quantum jitter in that first instant began to grow. Regions slightly denser than their surroundings pulled more matter in. Gas clouds collapsed. Temperatures rose again, not to the fury of the beginning, but just enough to ignite fusion. The first stars were born, lighting up a sky that had known only darkness. But that would come much later. For hundreds of millions of years, the universe remained starless, a warm, diffuse fog expanding slowly, cooling with every heartbeat of time. If you could float there, you'd see nothing, just dim radiation, the faint breath of heat stretching thinner with each passing moment. It would feel empty, but it wasn't. It was building towards something, waiting, and it all came from silence. That's what often gets lost in the telling, the quiet, not the violence, not the chaos, but the gentle unfolding of everything. Time itself isn't loud. Expansion doesn't roar. The Big Bang wasn't a scream. It was a sigh that never stopped. We live inside that sigh now. Your body, your breath, your pulse. All of it depends on the rules set in that first moment. The constants, the particles, the flow of entropy. The fact that time moves forward, not backward. That light travels at a fixed speed. That hydrogen exists at all. These are not givens. They were set when the universe was still less than a second old. And because of them, you are here, drifting, listening, wondering. There's something beautiful in that. Not just the scale, not just the science, but the calm of it. The universe didn't need thunder to begin. It didn't need drama. It only needed time. Time and space. And the smallest imperfections stretched large enough to become stars, galaxies, people, thoughts. Even now, we are still inside that beginning. The expansion hasn't stopped. The echo hasn't faded. And as we drift through it, one breath at a time, we are not apart from it. We are part of the silence it began with. And the story it is still telling. There is a speed limit in the universe, and it's not negotiable. No exceptions, no shortcuts, no hidden tunnels through the fabric of space. Light, traveling at exactly 299,792 kilometers per second, defines the upper boundary of motion, not just for beams and particles, but for information, for cause and effect, for the very structure of reality. It's not just fast, it's final. In all the vastness of the cosmos, nothing goes faster. Nothing ever has. Nothing ever will. You might imagine light as a streak through space, something that zips from one star to another like a message in a bottle. But it's more than motion. It's memory. Every ray of light you've ever seen is a courier of the past. Because light takes time to travel, every time you look into the sky, you're not seeing things as they are. You're seeing things as they were. The moon, 1.25 seconds ago. The sun, 8 minutes old by the time it kisses your skin. The nearest star system, 4 years away, even at light speed. You will never, ever see it as it is right now. The farther you look, the older the light becomes. And eventually, you hit a limit. Not because space ends, but because time does. The universe has only existed for about 13.8 billion years. That means the most distant light we can ever observe has been traveling toward us for that long and no longer. Beyond that, there may be more stars, more galaxies, more everything, but we'll never see them. Their light hasn't had time to arrive. So the edge of the observable universe isn't an edge in space, it's an edge in time. And that edge is always moving. Because even now, light is still arriving. Photons that have been flying across the void since before the Earth formed, since before the sun ignited, since before the Milky Way was the shape we know. These ancient messengers arrive without sound or ceremony. They don't burn or spark or shimmer. They simply reach your eyes and disappear. Their long journey ends in your glance, and they tell you, softly, what the universe once was. The light from galaxies billions of light years away isn't the light of today. It's the light of their youth. You see them as they were when life here was still a fantasy, when Earth was molten, when the atoms in your body had not yet found each other. That galaxy might not even exist anymore. It may have collided, collapsed, faded into embers, but its light is still traveling. Its ghost still glows. This is one of the strange gifts of the cosmic speed limit. Light is not just illumination, it's history. Every distant star is a chapter in the universe's autobiography, written in photons and drifting endlessly through space. The faster light moves, the more it reveals. And yet, it also defines what you can never know, because for all its speed, light is still finite. It cannot keep up with expansion. The universe itself is stretching, and in some distant corners, space is expanding faster than light can bridge. Galaxies in those far-off regions are receding from us faster than light can catch, not because they're moving through space that quickly, but because the space between us is growing. Their light is lost to us, not forever, but for as long as the rules remain, which is to say, for always. That means there are places you'll never see, places where stars are being born, where light is spilling across newborn planets, where entire civilizations might one day rise and fall. But their light will never reach us, not because they're too far, but because they're moving out of time's reach. Their stories will be written in silence. And still, here we are, perched on a small planet, spinning around an average star, watching ancient light trickle in from the edge of time. It's humbling, not just the distance, but the delay. Everything you observe is filtered through time, softened by billions of years. Even the starlight that falls on your skin tonight has been traveling so long it barely remembers where it came from. It doesn't know you. It doesn't mean to illuminate your hand or your pillow or your bedroom ceiling. But it does. And in that glow, you witness the past. You're not seeing the universe as it island. You're seeing what it was willing to share. Some things are simply too far gone. Some galaxies moved out of view long ago. Their light never aimed at us, or swallowed by distance, or stretched by redshift, until it fades into invisibility. The speed of light isn't just a limit, it's a filter, a quiet editor of what gets remembered. And in the quiet of night, as your thoughts begin to loosen, that limit becomes strangely comforting, because it means we are always tethered to the past, not bound by it, but illuminated by it. The stars in your sky are not strangers. They are messages, slow, steady, honest messages. They tell you that the universe is vast, yes, but it's also knowable. Not all at once, not completely, but piece by glowing piece. They tell you that time moves in one direction, that light always travels forward, that even in darkness, something is on its way. They tell you that limits aren't walls, they are invitations. And tonight, as you drift through this gentle current of light and thought and time, remember this: you are moving too. Not fast, not visible, but your atoms, your breath, your quiet heartbeat, they ripple through space with the same grace that starlight does. And somewhere out there, your light is traveling too. You might imagine galaxies as travelers, racing outward from a central explosion, flung like sparks from some ancient fire. But that isn't how the universe grows. The galaxies aren't flying through space. Space itself is stretching between them. It's not motion in the way we usually understand it. There's no wind in their faces, no thrust behind them, just the quiet expansion of the very fabric they're woven into, as if the threads of the cosmos are pulling apart, gently, endlessly, carrying every galaxy away from every other, not because they chose to move, but because the floor beneath them is stretching. This discovery came slowly. At first, astronomers thought the universe was still, eternal, and unchanging. A backdrop, a stage. But then, they began to measure the light from distant galaxies, and something strange emerged. The light wasn't quite what it should have been. It was stretched, softened, shifted toward red. Not because the galaxies themselves were glowing redder, but because the space their light traveled through had expanded on the way here, pulling each photon gently apart as it flew. This phenomenon is called redshift, a cosmic stretching of light, measured not in kilometers or seconds, but in patience and distance. The farther away a galaxy is, the more its light is redshifted, and the faster it seems to recede. It's not just that distant galaxies are far. It's that the space between us and them has grown since their light began its journey. In the time it takes that light to reach us, the universe expands beneath it. What began as a modest distance becomes enormous by the time it arrives. If you picture dots on a balloon and then inflate it, the dots don't move across the surface. The surface itself grows, and the space between them widens. They aren't propelling themselves. The expansion carries them. That's how galaxies move. Not by effort, by distance, multiplying. It's easy to forget how strange that island, that the empty space between stars and galaxies isn't static, that it has properties, that it can change, stretch, evolve. We think of space as a void, but it has structure, rules. It can bend under gravity, vibrate with energy, ripple with gravitational waves, and it can grow, not into anything, but of itself. This expansion doesn't affect everything equally. Your body doesn't stretch. Earth doesn't expand. The space within galaxies remains mostly stable, held together by gravity. It's only over immense distances, the gulfs between clusters of galaxies, where the expansion becomes noticeable. And over billions of years, those distances have grown so vast that entire galaxies now appear to race away at incredible speeds. Not because they're fleeing, because the universe is unfolding. There's no center to this expansion, no privileged point from which the stretching radiates. Every point in space sees every other point moving away. If you lived in another galaxy, you'd see the same thing. Distant galaxies drifting outward, the same redshift, the same spreading silence. Expansion is not something we observe from the edge. It's something we live inside of. And it's not slowing down. In fact, it's speeding up. For reasons still not fully understood, the rate of expansion is increasing. Galaxies aren't just receding, they're accelerating. The farther away they are, the faster they vanish from view. This acceleration is driven by something we call dark energy, a placeholder term for a force we haven't yet explained. It makes up most of the universe. We don't know what island, only that it's there, quietly pulling the universe apart. This means that over time, more and more of the cosmos will move beyond our horizon. Galaxies we can see now will someday be too far, their light stretched thin into invisibility. Not because they're gone, but because they've slipped beyond the limits of what light can reach. The observable universe will shrink, even as the actual universe grows. And eventually, only the local group of galaxies, those closest to us, gravitationally bound, will remain visible in our skies. The rest will fade into darkness, not with a bang, but with distance. This isn't a tragedy. It's just the nature of space. The universe has no obligation to remain within our reach. It moves to its own rhythm, and that rhythm, for now, is expansion. It's humbling to think that the stars we see are only a fraction of what's out there, that the galaxies glowing faintly in deep field images are already receding faster than we can follow, that some of them will one day vanish from the sky entirely, not because they've died, but because space has carried them away. And yet, in this slow stretching of everything, there's a kind of grace. The galaxies aren't falling apart. They're not panicking. They drift with the calmness of age, the elegance of time unfolding. Expansion is not chaos. It's breath. The universe, exhaling. Right now, you are part of that breath. You are riding the fabric of space as it expands beneath you. Your atoms are bound together tightly enough to resist the pull. But the light entering your eyes tonight has felt it. The air between stars has lengthened. The dark has deepened. And still, the cosmos stretches forward, not into a void, but into itself. In 1995, scientists pointed the Hubble Space Telescope toward what looked like nothing, a small, blank patch of sky near the Big Dipper. No stars, no galaxies, just emptiness. The size of a grain of sand held at arm's length. They left the telescope staring there for 10 days, collecting light from the deepest dark it could see. What came back wasn't nothing. It was everything. Thousands of galaxies revealed themselves. Not stars, but entire galaxies, each one packed with billions of suns, spirals, ellipticals, irregular swirls. Some were shaped like wheels, others like smudges of breath on glass. Some were bright and close, others were dim and unimaginably distant, their light stretched by billions of years of travel. What had looked like void was in fact crowded. The universe, it turned out, was far busier than we had ever guessed. That image became known as the Hubble Deep Field, and it changed the way we understood the cosmos. Because if thousands of galaxies could hide in that one tiny sliver of sky, a spot no larger than the tip of a pencil held at arm's length, then the full sky must be filled with them. Not hundreds, not thousands, not millions, but more, much more. Current estimates now suggest there are over 2 trillion galaxies in the observable universe. 2 trillion vast cities of stars floating through space like glowing islands. And that's just the part we can see. Each of those galaxies contains billions, sometimes trillions, of stars. Some no bigger than a candle flame, others large enough to swallow entire solar systems. Some galaxies are small and dim, home to a few million suns. Others are enormous, stretching hundreds of thousands of light years across, with central black holes weighing billions of times more than our own Sunday. And they're not just scattered at random. They gather in clusters, form filaments, align along invisible structures shaped by dark matter. They move, they collide, they merge, they grow old, they die. And yet, to the naked eye, most of it is invisible. When you look up at the night sky from a dark place, you might see a few thousand stars. That can feel like a lot, but it's barely a whisper. Almost every point of light you see belongs to our own galaxy, the Milky Way. Those stars are local, familiar, neighbors. Beyond them, the sky is flooded with galaxies you'll never see unaided. They don't twinkle, they don't call attention to themselves, but they're there, quiet, ancient, watching. It's not just the number that's staggering, it's what those galaxies contain: planets, clouds, moons, nebulae, black holes, time, the ingredients for life, the ruins of other beginnings. You could spend a lifetime exploring one single galaxy and never run out of questions. And there are trillions more waiting. Every direction you point your mind, there is more. The light from some of these galaxies began traveling toward us before Earth even existed, before the sun had formed, before our galaxy had its current shape. That means when you look at them, even in photographs, you're seeing them as they were billions of years ago, not as they are. You're peering through layers of time, one photon at a time. Some galaxies no longer exist. Their light is still on its way, like a postcard from a traveler who's already gone. Others are so far that their light will never reach us. Not because they're hiding, but because the universe is expanding. The space between us is growing faster than light can bridge. They are there, but we will never see them. We can only imagine their glow. And yet, all of it, every galaxy, every star, every cloud of gas, emerged from the same beginning, the same moment of sudden expansion, the same raw ingredients, the same laws. That moment did not sprinkle galaxies into the void like stars on a map. It created the space and time that galaxies would eventually inhabit, and ever since, they've been drifting apart, like lanterns on a dark river. 2 trillion galaxies, more than the number of grains of sand on every beach on Earth. And yet, it's not just numbers. Each galaxy holds its own story. Some are quiet, aging peacefully in the emptiness. Others are chaotic, colliding, stretching, birthing new stars in clouds of turbulence. Some are shaped like disks, some like cigars, some like shattered glass. And in one of them, a fairly ordinary spiral called the Milky Way, there is a solar system. In that solar system, a small blue planet. On that planet, you, listening, drifting, breathing. You are part of this web, not a visitor, not a footnote, but a continuation. The atoms in your body were forged in stars that once lived in galaxies that may no longer exist. Their light has faded, their shapes forgotten, but their remnants remain, flickering quietly in you. Tonight, as you close your eyes and float into the dark, remember this. The sky is not empty. It never has been. It only appears that way from here. The universe is full, full beyond imagining, full beyond counting, and all of it, somehow, is still expanding, still becoming, still waiting to be seen. If you could zoom out far enough, not from Earth, not from the galaxy, but from the entire cosmos, and look at the universe as a whole, what shape would it have? Would it curve inward like a sphere, looping back on itself in some endless spiral? Would it curve outward, like a saddle, falling away into infinite descent? Or would it be flat, not flat like paper, but flat in a more abstract mathematical way, where space stretches evenly in every direction and never curves at all? Strangely, the best evidence we have suggests the universe is flat, not in appearance, not in feeling, but in geometry. On the largest scales, across billions of light years, space doesn't seem to bend or warp in any consistent direction. It follows the rules of classical, Euclidean geometry, the same kind you learned as a child. If you draw a triangle between 3 distant points in the universe, the angles will add up to 180 degrees. If you draw 2 parallel lines, they will never meet. Light travels in straight paths unless distorted by gravity, and those distortions are local, not built into the fabric of the universe itself. This isn't just an abstract curiosity. The shape of the universe tells us about its past and its future. If the universe were curved inward, like the surface of a sphere, it might one day collapse back into itself, reversing the Big Bang in a final contraction, sometimes called the Big Crunch. If it were curved outward, like a saddle, it might expand forever, but in a way that stretches everything thinner and thinner until galaxies are torn apart by the growing void. But in a flat universe, expansion continues, driven by dark energy, with no dramatic reversal or runaway tear. Just a long, slow drifting into darkness. The flatness was first suggested by measurements of the cosmic microwave background, the afterglow of the Big Bang. Tiny fluctuations in this background radiation give us a snapshot of the early universe, and by studying the size and distribution of those fluctuations, scientists can infer the geometry of space itself. What they found was stunning. Space, on the largest scales we can measure, appears flat to within a tiny margin of error, not curved, not folded, just vast and even, like a canvas that goes on forever. But this flatness raises questions, because in the early universe, space would have been shaped by extreme energies, chaotic motion, the quantum turbulence of the first fractions of a second. Maintaining perfect flatness through all that chaos would be like balancing a pencil on its tip during an earthquake. And yet, here we are, in a cosmos that seems to have held that balance for billions of years. One explanation is cosmic inflation, a brief moment just after the Big Bang when the universe expanded faster than the speed of light. Not breaking the rules, because it wasn't objects moving through space, but space itself, expanding outward. This burst would have ironed out any wrinkles, stretched any curvature flat, like a balloon blown so large that its surface feels smooth no matter what shape it started as. Inflation didn't just make the universe big, it made it geometrically neutral. But flatness doesn't mean emptiness. The universe is still filled with structure, galaxies, clusters, filaments, voids. Gravity still bends light. Space still curves around mass, but those are local deformations, like hills and valleys on an otherwise flat plane. The underlying structure remains even, extending in every direction without intrinsic bend. And in that structure, everything we know, every star, every planet, every breath you take, unfolds. Flat space also means light can travel in straight lines indefinitely. In a curved universe, light might loop back around eventually, allowing you to see the back of your own head from billions of light years away. In a flat universe, light just keeps going, outward and outward, never circling, never returning. Which means there are directions in the sky where light will never meet itself, never wrap around, never echo. Just one-way corridors into the unknown. And yet, even this flatness has a boundary. Not in space, but in time. The observable universe only stretches as far as light has had time to travel since the beginning. Beyond that, we can't say. The universe might still curve. It might still wrap. But if it does, the radius of that curvature must be so vast that we cannot detect it. Not yet. Maybe not ever. The flatness we see may be only the middle of something far stranger. And what does this mean for the end, if the universe is flat, and if dark energy continues to accelerate its expansion, then everything we know will drift apart. Galaxies will vanish from view, their light stretched into silence. Stars will burn out, planets will freeze, black holes will fade. The universe will not collapse or explode. It will dim, slowly, quietly, forever. But that's not a cause for sorrow. It's a kind of serenity, a long, soft exhalation of everything, a story without a final punctuation mark, just ellipses, just breath. Tonight, as you rest in your small corner of this flat and drifting cosmos, remember that you are lying on a plane of space so vast it cannot be measured, so even it might as well be infinite, so finely balanced that it has held its shape for nearly 14 billion years. You are not standing on a stage. You are floating on a field that goes on forever, and that field is still unfolding, still stretching, still waiting for its next chapter to be written in starlight. For most of human history, it was assumed that the universe must be slowing down, that gravity, even spread thin across billions of light years, would tug at galaxies and gradually ease their outward drift. Like a ball thrown upward, eventually pulled back by the invisible hand of its own weight. The cosmos, too, was expected to slow, maybe even fall back inward. It seemed natural, orderly, predictable, but the universe had other plans. In the late 1990s, two separate teams of astronomers studied distant supernovae, ancient stellar explosions so bright they can outshine entire galaxies for brief moments in time. These explosions serve as cosmic yardsticks, their light helping us measure distances across the vastness of space. The astronomers expected to find signs of slowing expansion, the gradual fatigue of a universe stretched thin. Instead, they found the opposite. The most distant supernovae weren't dimmer because they were farther than expected. They were dimmer because they were accelerating away. The light was older than it should have been, fainter, redder, as if the space between us and them had grown faster than anyone imagined. It wasn't a gentle deceleration. It was a cosmic lurch outward. Something was pushing the universe apart. That something is now called dark energy, a placeholder name for a force we don't yet understand, but can't ignore. It makes up roughly 68% of everything. Not just everything you can see, or touch, or measure, but everything that exists. More than stars, more than galaxies, more than all the dark matter we still haven't seen. A force with no shape, no sound, no particle to pin it down. It doesn't clump. It doesn't glow. It doesn't form planets or bind atoms. But it dominates the cosmos. And it's accelerating everything away. We don't know what dark energy island. Not really. It could be a property of space itself, an energy woven into the vacuum, growing stronger as space expands. Or it could be something else entirely, a dynamic field, a new dimension, a wrinkle in the way we understand time. For now, it is a mystery, wrapped in math, a pressure without a face, the quiet breath behind the universe's expansion. But its effects are everywhere, every second. Galaxies grow more distant, not because they are fleeing under their own momentum, but because the space between them is being pushed wider. Like ink dots on a stretching balloon, they aren't moving across the surface. The surface itself is changing, and the farther they are, the faster they recede. This isn't inertia. It's acceleration, a runaway drift with no obvious end. In the early universe, gravity was stronger, matter was denser. The push of dark energy was there, but muted, drowned out by the weight of things. Expansion was slowing, briefly, but as matter thinned and galaxies spread out, gravity weakened. And dark energy didn't. It stayed constant, or maybe even grew stronger. Eventually, its influence tipped the balance, and acceleration began. It hasn't stopped since. This change in the universe's behavior didn't just rewrite textbooks. It reshaped our understanding of the future. If dark energy continues to push, unchecked and eternal, the universe will not end in fire or collapse. It will end in coldness, in distance, in silence. Galaxies will drift so far apart that their light can no longer reach each other. Stars will burn out. Black holes will evaporate. And space will stretch so wide that even particles will struggle to find one another. Not a crash, not a bang, just an endless quiet. It's called the heat death of the universe, not because it ends in heat, but because all usable energy fades into uniform stillness. Entropy wins, structure dissolves. Time, as we know it, becomes meaningless. There will still be space, still be particles, still be distance, but no story left to tell. Just a low, even hum of nothing in particular. And the force behind it? A quiet pressure, a whisper between atoms, dark energy. But for now, it's not something you can feel. Not in your body, not in your breath. Its effects are measured in billions of light years, in the drift of galaxies you will never see. It doesn't pull at your skin or weigh down your mind. It works at the edges, in the silence between galaxies, in the dark beyond the stars, and yet it shapes everything. Because of dark energy, the night sky will one day change. Galaxies now visible through telescopes will disappear from view, not because they've vanished, but because they've moved beyond the cosmic horizon. Their light will never reach us again, not in a year, not in 1,000,000,000,000 years. They will become invisible, not through fading, but through expansion. Like ships sailing over an ever-widening ocean, vanishing not because they sank, but because the shoreline receded behind them. The universe is not just expanding, it is accelerating, and the driver is something we cannot see. And tonight, as you lie still, the galaxies continue to drift. Their light grows fainter. The space between them stretches, molecule by molecule, light year by light year. The stars do not protest. The void does not resist. It simply opens. And in that quiet expansion, in the pressure of a force we don't yet understand, the future is being written, slowly, patiently, without sound, without end. Time does not flow evenly. It may feel that way, measured by clocks, calendars, heartbeats. But the truth is stranger. Time bends. It stretches. It stalls. Depending on where you are, how fast you're moving, and what kind of gravity is pressing against you, time can change. Not just in theory, not metaphorically, but in the deep architecture of reality. Time is not a constant stream. It is a landscape shaped by the curves and folds of space itself. This idea was once unthinkable. For centuries, time was assumed to be fixed, ticking forward at the same pace for everyone, everywhere. But then came Einstein, and with him, a new way of seeing. His theory of general relativity showed that gravity isn't a force pulling on objects across space. It's the curvature of space itself. Mass warps the fabric of space-time, and in doing so, it affects how time passes. Where gravity is strong, time slows. Where gravity is weak, time flows more quickly. The universe does not keep one clock. It keeps many, and none agree perfectly. You are feeling this effect right now, whether you notice it or not. If you lie on the ground, you are aging more slowly than someone standing on a ladder. The difference is microscopic, but it's real. If you climb a mountain and spend a year there, you will be ever so slightly older than your twin who stayed at sea level. Gravity pulls more strongly near the Earth's center, and the closer you are to that pull, the slower your seconds pass. To most of us, that variation is invisible, but to time itself, it matters. Even our satellites feel it. The global positioning system depends on precise timing to work. The atomic clocks aboard the satellites must remain synchronized with those on the ground, but they don't. The satellites orbit high above Earth, where gravity is weaker, and so their clocks run faster. Not by much, just a few microseconds per day. But even that tiny difference can throw off a GPS location by miles. To correct this, engineers program the satellites to account for time dilation. Our navigation systems only function because we've embraced the fact that time flows differently in the sky than it does on the ground. In stronger gravitational fields, the effect becomes more pronounced. Near a neutron star, time would crawl. Near the event horizon of a black hole, it would almost stop entirely. From a distance, you could watch someone fall toward a black hole and see them freeze at the edge, their last moment stretched out indefinitely. They wouldn't feel it. To them, time would pass normally. But from the outside, they'd be locked in slow motion, their seconds spilling like molasses into the void. This isn't science fiction. It's woven into the equations that govern the universe. It has been tested, measured, verified. Time dilation is not a theory waiting for proof. It is part of the fabric of reality. The same principles apply to speed. The faster you move through space, the slower you move through time. A particle traveling near the speed of light ages more slowly than a stationary one. Astronauts aboard the International Space Station orbit Earth at over 28 kilometers per hour. They experience time just a bit more slowly than people on the surface. Over the course of a year, the difference adds up to a fraction of a second. But in a universe built on precision, even a fraction is enough to reveal the truth. It means time is not absolute. There is no single, shared now. Every observer experiences a slightly different version of reality. And while those differences are tiny in our everyday lives, they become vast over cosmic distances and extreme conditions. Two clocks, placed at opposite ends of the galaxy, will not agree. Two travelers, moving along different paths through curved space-time, will not age at the same rate. The universe does not tick in unison. It breathes in variations. This bending of time has poetic implications. It means the past and future are not fixed rails. They are coordinates on a shifting map. It means that the story of the universe is not told in one voice, but in many, overlapping, conflicting, harmonious. And it means that time travel, at least in one direction, is already happening. We are all moving forward in time, but not at the same pace. You are living proof of this. Your heartbeat, your memories, your aging, they are unfolding in a slice of space-time that is unique to you. Right now, as you listen, someone high above you is living just a little faster, and someone deeper underground is living just a little slower. The difference won't change your day, but it changes everything, because it means time is not a river flowing from one source to one sea. It is a fabric, pulled and twisted by mass and motion. It is not universal. It is personal. And in that small, strange truth lies a kind of freedom. You are not confined to a single tempo. You are part of a dance where every step moves differently. A gravity-warped waltz that bends clocks and stretches lifetimes. You are not late. You are not early. You are simply drifting through your own corner of time, 1 second at a time, in a universe that refuses to tick evenly. You'd think the beginning of everything would feel grand, that it would arrive with symbols, with brilliance, with clarity. But if the current theories are even close to right, the universe began with something closer to a murmur. Not a bang, not a trumpet, just fluctuation. Tiny, quantum-sized jitters in the fabric of nothing. Not even space yet. Not really. Just a churning uncertainty so small you couldn't point to it, but so powerful it became everything. It's hard to imagine a time before time, a place before space. The mind recoils because it wasn't darkness and it wasn't silence and it wasn't waiting for something to happen. It was simply not yet. And from that not yet came the first whisper of structure, thanks to quantum mechanics. Particles popping into and out of existence. Probabilities behaving like dice with infinite sides. Fluctuations that didn't even require a cause, because at that scale, cause and effect are slippery things. One tiny patch of that uncertainty inflated, fast, not through space, but as space. It wasn't a starburst or a shock wave, it was expansion, sudden, relentless, a stretching of what once wasn't, faster than light itself, creating not just the canvas, but the very idea of a canvas. This wasn't an explosion in space. It was space being born in every direction at once. The fire didn't erupt into the void. The void was born from the fire. And those little fluctuations, those quantum jitters that had no plan, no purpose, they were frozen into the expanding fabric. Tiny wrinkles stretched across unimaginable distances. Imperfections so small they should have meant nothing, but they became everything. Those wrinkles are why matter clumped, why galaxies formed, why stars were possible, why you are here. You were written in the static, the oldest light in the universe. The cosmic microwave background still holds a faint fingerprint of those fluctuations. We've mapped them, seen the scatterplot of the universe's earliest dreams, captured in microwaves, humming faintly in every direction. It looks like noise, it looks like randomness, but inside, it is the reason why anything at all is possible. There's something beautiful and almost unfair about the fact that the universe didn't have to exist, that it wasn't designed or chosen or forged by anything with a plan, that it simply began jittering, and that jittering somehow led to laws and stars and planets and laughter and the little ache behind your ribs when you look up too long at the night sky, all because a quantum field didn't stay perfectly still. Stillness was never sustainable. Even nothing, it turns out, is unstable. You can call it quantum foam, a sea of potential, a flickering veil beneath all matter. Every second, even now, particles are appearing and disappearing inside you. Virtual, fleeting, fizzing with borrowed energy. Some theories say the entire universe did the same, that ours is just one bubble in a never-ending froth. That universes are born like sparks from a fire, flaring briefly, each with its own physics, its own time, its own unknowable story. Maybe most collapse instantly, maybe ours is just lucky. Or maybe this is what universes do. They fluctuate, they inflate, they cool, and eventually they go quiet. But we're not there yet. We're still in the story, still riding the echo of that original shudder, still cradled inside a space that had no precedent, no example, no cause, just the strange momentum of a question without an answer. You don't need to solve it. You don't need to grasp quantum mechanics, or remember the names of particles, or fold your brain into string theory. All you need to know, right now, as your breath slows and the covers hold you like gravity once held galaxies, is this: everything that exists, including you, comes from something that didn't. And yet, somehow, here you are, drifting in a bed made of starlight and silence, listening to a story that began before atoms existed, a soft murmur from the earliest moment, still rippling outward, still shaping the world, still whispering across the fabric of time. Sleep now. The quantum foam will still be bubbling when you wake. There is no pull. That's the first strange thing to understand about gravity, at least if you grew up thinking it was some invisible hand dragging apples from trees and moons around planets. It's not a tether. It's not a string. It's not even really a force. Not in the classical sense. Gravity, as Einstein redefined it, is the shape of space itself. And the more massive something is, the more it bends that shape. Mass tells space how to curve, and curved space tells everything else how to move. Imagine laying a bowling ball on a trampoline. The surface dips under the weight, forming a basin. If you roll a marble near the edge, it doesn't fall in because it's pulled. It rolls inward because the fabric beneath it is no longer flat. It curves. That's what Earth does to space. That's what the sun does, more dramatically. It's not casting some invisible net. It's denting the stage everything else moves across. Earth isn't being tugged toward the sun like a fish on a line. It's caught in the shape of space-time, following the deepest groove carved out by the sun's mass. It moves not because it's yanked, but because the straightest path in that curved landscape happens to be a circle or something close to one. And so, Earth falls forever, not downward, but sideways, orbiting through a curved sheet that you can't touch, but that defines everything. The moon does the same thing with us. Satellites do it too. They're not dangling like Christmas ornaments from invisible threads. They're riding the geometry of a warped reality, looping along the soft hills and valleys carved into space by Earth's weight. They coast, effortlessly, obeying a rule written into the floor beneath them. This is what the shortest path looks like here. Einstein's insight shattered the old picture. For Newton, gravity was an instant action at a distance. Mass A exerting a force on mass B, no matter how far apart they were. It worked well enough to launch cannonballs and land on the moon, but it was incomplete. It couldn't explain why light bends near stars, or why time runs slower at sea level than atop a mountain. It couldn't handle the weirdness of high speeds and enormous scales. Relativity did, and in doing so, it revealed that space isn't just the emptiness between things. It's a participant. It bends, it flexes, it flows like honey under pressure. Space and time aren't separate arenas. They're stitched together, part of one woven whole. When a star collapses, it doesn't just become denser. It stabs a deep pit into space-time, one so sharp that nothing, not even light, place, can escape. That's a black hole, not a vacuum cleaner in space. A place where the map of reality folds inward on itself. But even here on Earth, in your body, this curvature is happening. You are curved into space right now. Your feet rest on a floor that curves toward Earth's center. Your muscles compensate for that curve, pushing up. If they stopped, you'd fall. Not because of an external force pulling you down, but because the floor beneath you is not flat. It never was. Even light feels this curve. When it passes near a massive galaxy, the path bends. From our perspective, it's as if the light has changed course, but in truth, it's simply following the geometry. The straightest line through a bent fabric is itself bent, and this bending can create illusions. Duplicate images of distant stars, rings of light, distortions called gravitational lensing. The cosmos becomes a hall of mirrors, shaped by the quiet weight of mass. This idea, gravity as geometry, has been tested again and again. It predicted the way Mercury's orbit shifts. It predicted how starlight would curve during an eclipse. It predicted the slowing of time in stronger gravity, and the ripples of space-time known as gravitational waves. Those waves, detected in 2015, are not sound. They are shudders in the fabric of the universe itself, triggered by colliding black holes. Like rings on a pond, they carry information, not about what was there, but how the water moved. And still, we are only beginning to understand what it all means. Because if gravity is not a force, but a shape, then the universe is a dance of curves. Everything moves because it must. Planets orbit because the space around their stars is bent. Galaxies spin because they're embedded in a warped web of dark matter. Even time flows differently, not because of clocks, but because of the landscape those clocks move through. We walk across invisible hills. We sleep inside valleys too vast to see. Every object, every atom, sinks into the fabric just a little, and everything else feels that dent. You are part of it. Your mass bends space, infinitesimally. It's not enough to trap light or alter orbits, but it's there. You bend the floor as you walk. You reshape time as you move. You are not a passenger in this universe. You're woven into it, stitched along the same threads that guide planets and cradle stars. And tonight, as you lie still, Earth continues to fall sideways through the gentle curve of the sun's basin. Not tumbling, not yanked, just gliding along the shape it cannot escape. There is no pull, only the quiet truth that the shortest path is rarely a straight line. Black holes are not things. They are not objects in the usual sense, not spheres of matter or pits you could fall into and climb out of. They are places where the rules end. Not because they're broken, but because they're followed so perfectly that reality folds in on itself. They are born from mass, but what they become is not mass. They are made of nothing, and they are made of everything. A black hole begins with collapse, not the dramatic explosion of a dying star, but what comes after. When the star has burned through its fuel, when its pressure can no longer fight against the pull of its own gravity, it folds inward. It doesn't stop at dense. It doesn't stop at compressed. It keeps going, past atoms, past quarks, until all that was something becomes a point, with no surface, no volume, no space left to give. This point is called a singularity, and around that point, a veil forms, the event horizon. This is not a wall or a surface. It's a boundary, a threshold. From the outside, it marks the place where light itself loses the ability to escape. Not because something is holding it back, but because the curvature of space-time is so extreme that all paths lead inward. Inside the event horizon, all directions point toward the singularity. Down is inward. Up is inward. Even standing still carries you closer to the center. Escape is not forbidden. It is geometrically impossible. What's strange is that this boundary has size. The black hole from the outside appears to have a radius, a diameter, a gravitational presence that can be measured. You can orbit it. You can feel its pull. And yet what lies inside occupies no space at all. A black hole contains no matter you can touch, and yet it can outweigh millions of suns. It is made of curvature, made of absence, made of everything that once was, compressed into a silence that can no longer speak. Some black holes are small. These are formed from stars like our Sunday, if our sun were a few times more massive. When these stars die, their cores implode and leave behind stellar mass black holes, just a few kilometers across. They drift in the dark, invisible, unless they happen to be feeding. When they do, the infalling matter heats up, spinning around the event horizon and glowing with the heat of friction and doom. We see these flashes and infer what must be hiding at the center, but others are enormous. At the heart of nearly every galaxy, including ours, lurks a supermassive black hole, not a few kilometers wide, but millions, some billions. They didn't form from single stars, but through mergers, accretion, and time. And far from being destructive voids, they may be the engines of creation. It's a strange irony. These regions where light cannot escape may be responsible for lighting up the early universe. When galaxies were young, supermassive black holes gorged on surrounding matter, unleashing jets of energy, forming quasars that outshone everything around them. Entire galaxies flickered like beacons because of the chaos around the calm. But not all black holes feed. Some drift silently. They don't glow or pulse. They don't consume or reveal. They are known only by their gravity, by how nearby stars curve their paths or vanish without explanation. They are not active. They are not asleep. They simply are. It's easy to think of them as monsters, as vacuum cleaners of space, but black holes do not reach out. They do not pull beyond their gravity. If you replace the sun with a black hole of equal mass, Earth's orbit wouldn't change. It would remain the same cold ellipse, just darker. What makes a black hole dangerous isn't suction. It's inevitability. Cross the horizon, and the geometry no longer permits reversal. You will fall, not because you are weak, but because the structure of space says you must. What happens at the center, no one knows. The equations break down. Time, as we understand it, ceases to function. Space shrinks to zero. Information, what went in, how it fell, what shape it had, may be lost or stored or smeared across the event horizon like a hologram. This is the black hole information paradox, and it still baffles the best minds in physics. Some think that information is never truly destroyed, only scrambled beyond recovery. Others suspect we're missing a deeper theory entirely. Something quantum, something gravitational, something that marries both in a way we've never seen. But here's the quiet miracle. Black holes are not exotic outliers. They are woven into the story of the cosmos, born from death, but capable of shaping birth. They anchor galaxies. They sculpt matter. They seed structure in the void. They are not mistakes. They are essential. And in some theories, they are doors, not to other universes, not in the way science fiction likes to dream, but as bridges. Mathematical tunnels in space-time called wormholes. Hypothetical, unstable, maybe impossible. But the math permits them. And in a universe this strange, permission is the first step. Tonight, the nearest known black hole is thousands of light years away. It hums with mass, silent and unseen. And beyond that, millions more drift in the dark. Some spinning, some quiet, some swallowing the light of stars, some waiting for their next meal. You will never see one up close, but they see you, not through eyes or thought, but through the shape you help give to the universe, through the gravity you contribute, through the story you are quietly a part of. Because a black hole is not a thing, it is a shadow cast by presence, a memory of mass, a curve so deep it folds the rules into something new. And tonight, as stars wheel overhead, you are closer to one than you've ever been. When a massive star dies, it doesn't go quietly. It collapses in on itself with such violence that the outer layers explode outward in a blaze of light and energy. A supernova, bright enough to outshine entire galaxies for a brief moment in cosmic time. What's left behind depends on the size of the original star. Sometimes, gravity wins completely, crushing the core into a black hole. But if the balance is just right, massive, but not too massive, something even stranger forms. A neutron star. Calling it a star feels almost misleading. There's no flame, no flickering surface, no light escaping from its depths. It doesn't shine in the usual way. It radiates, yes, but not because of nuclear fusion. That part is over. The neutron star is what's left when a star's core collapses under its own gravity, compressing protons and electrons into neutrons, forcing the very structure of matter to fold in on itself. What's left is a city-sized sphere of almost pure neutron matter, no wider than Manhattan, but heavier than the Sunday. You could hold a teaspoon of it in your hand, if your hand weren't instantly obliterated. That single teaspoon would weigh about 6 billion tons. More than all the cars, all the buildings, all the mountains on Earth combined, compressed so tightly that atoms no longer exist in the form we know them. The spaces between electrons and nuclei, the ones that make up everything familiar, are gone. There's no room for empty space anymore. Only neutrons, shoulder to shoulder, in a quantum pileup of unimaginable density. And yet these objects are real. They spin, sometimes slowly, sometimes so quickly that they blur time itself. Some neutron stars rotate hundreds of times per second. These are called pulsars, and they beam radio waves from their magnetic poles like cosmic lighthouses. When their beam sweeps across Earth, we see a pulse, steady, predictable, like a ticking clock made of ghost matter. Some of these pulsars are so precise that they rival atomic clocks in stability. Their rhythms haven't changed in millions of years. Not because they're immune to change, but because they're built from something so stable that the universe itself seems to take a breath between their pulses. You can think of them as dead stars, but they're not silent. Their birth is violent. When a star goes supernova and leaves behind a neutron star, the shock waves ripple across space. The explosion sends elements like gold, platinum, and uranium scattering through the galaxy. You are wearing pieces of old neutron stars. Your bones hold calcium born in stellar hearts. The iron in your blood, forged in their death throes. Every time a massive star dies, it writes new ingredients into the cosmos. And the neutron star that remains is the gravestone that still echoes. Not all neutron stars are alike. Some are quiet, cold, and alone. Others exist in binary systems, locked in orbit with a companion star. When that companion strays too close, the neutron star begins to feast, stealing gas and matter, spinning faster and faster as it feeds, dragging light down into its gravity well. The infalling material glows in X-rays, revealing the predator beneath the quiet surface. And sometimes, two neutron stars collide. When they do, the collision sends ripples through space-time itself, gravitational waves that stretch and squeeze the fabric of the universe. We've seen these collisions. In 2017, observatories around the world detected the telltale signature of two neutron stars merging. What followed was a wave of light, gamma rays, and heavy elements, the building blocks of worlds. That single moment scattered enough gold into space to seed thousands of planets. We watched the cosmos forge treasure from its dead. These collisions may even create black holes. If the mass of the merged object exceeds a certain limit, gravity takes over completely, and the star that was, already more dense than anything we can touch, vanishes into a singularity. But before it disappears, it reshapes everything around it. Space, time, the very elements of the periodic table. What's haunting is how small they are. You could drive across one in under an hour, if you weren't instantly crushed by gravity a billion times stronger than Earth's. Their surfaces are so hard, their gravity so absolute, that dropping a marble from waist height would release more energy than an atomic bomb. The crust is a shell of nuclear matter, possibly the strongest substance in the universe, strong enough to support mountains less than a millimeter high. Any taller, and gravity would flatten them. They are alien, and yet they obey the same rules that guide everything else: mass, motion, collapse, pressure. They are what happens when the universe folds itself into a ball, when the distance between atoms is erased, and when matter refuses to disappear completely. They're the afterthoughts of supernovae, residues of ancient fire, pulsing in the dark, like the heartbeat of something that doesn't remember how to die. Somewhere, out there, a neutron star is spinning right now, unseen, sending out radio pulses into the void. It doesn't care who hears. It doesn't know that anything else exists. It just turns, slow or fast, across eons, shrinking its spin with each whisper, each silent beam sweeping the dark, like a lighthouse for no one. But we catch it, sometimes, and when we do, it reminds us what the universe is capable of, that density and silence can coexist, that violence and order are not opposites, that death can leave behind something stranger than life, and that sometimes, in a galaxy full of stars, the most remarkable thing is the one that no longer shines. Inside the heart of a star, something quiet and extraordinary is happening. Hydrogen, the lightest and simplest element in the universe, is being crushed together by gravity, not with violence, not with sparks and smoke, but with patience. Pressure building, atoms colliding, and a transformation unfolding in utter silence across millions, sometimes billions of years. What begins as a cloud of gas suspended in space eventually becomes an engine, one that burns without fire, churns without noise, and glows not just with light, but with possibility. This is fusion. It is not just a reaction. It is the beginning of everything we can see, everything we touch, everything we are. It starts small. Hydrogen atoms drawn together, forced so close that they fuse into helium. In doing so, they release energy. That energy pushes outward against gravity's endless pull, creating a delicate balance. That's what keeps a star alive. That's what makes it shine. But hydrogen doesn't last forever. Over time, the hydrogen supply begins to dwindle. The star becomes unstable. The pressure shifts. The core contracts. And now the helium begins to fuse into heavier elements: carbon, oxygen, neon. Each step up the periodic ladder brings more complexity, more energy, more chaos. In the largest stars, the process continues all the way to iron. But iron is different. Fusing it doesn't release energy. It absorbs it. And that's when the balance breaks. When a star can no longer produce outward pressure through fusion, gravity wins. The core collapses. The outer layers are blown into space in one final act of brilliance, a supernova. In the wreckage, something beautiful is scattered: carbon for your cells, oxygen for your breath, calcium for your bones, gold for your rings. Every element heavier than hydrogen was born in one of these furnaces and then ejected into the void to wander. Eventually, some of that debris found its way to a new cloud. That cloud collapsed again. A second-generation star was born. Planets formed. Life emerged. And you, somehow, impossibly, showed up to listen to a story about stars. You are, quite literally, made of stardust. Every beat of your heart, every thought that sparks in your mind, every breath you've ever taken, all of it powered by atoms that began their journey in the core of long-dead stars. You are not a visitor to the universe. You are a consequence of its fire. And yet, the stars don't burn for us. They were never aware of us. They don't know we exist. They shine because that's what they were born to do. They live long, silent lives. They swell, shrink, explode, collapse. Some become white dwarfs, dense, faded remnants cooling slowly over eons. Others go out more dramatically, collapsing into neutron stars or disappearing entirely into black holes. Their final acts are not failures, they're transformations, the end of one life feeding the beginning of another. Even the Sunday, warm, familiar, constant, is only temporary. It has been burning for over 4.5 billion years. It has about 5 billion more to go. When it runs out of hydrogen, it will expand into a red giant, swallowing Mercury, Venus, and perhaps Earth. Then it will shed its outer layers in a final breath, leaving behind a glowing shell of gas and a tiny white dwarf at the center, cold, fading, alone. But even that death will not be in vain. It will enrich the galaxy with elements. It will write new stories in gas and dust. And somewhere else, someday, that material may drift into a new cradle, a new star, a new solar system, a new set of possibilities. The cosmos doesn't waste. It recycles its ingredients endlessly, through fire and pressure and gravity and time. Stars are its engines, not just of heat and light, but of creation. They are alchemists, turning the simplest things into the most complex, and scattering the results into the wind, which means that the night sky isn't just beautiful. It's a map of process, memory, and origin. Every point of light is a forge. Every constellation is a family of ancestors. When you look up, you're not just seeing stars. You're seeing the factories that made you, and they are still at work. In the Orion Nebula, infant stars are flickering into life. In the arms of spiral galaxies, clusters of blue giants blaze fiercely before burning out in a few million years, a blink of cosmic time. In the quiet reaches of space, old red dwarfs simmer slowly, destined to outlast almost everything else. There are stars being born, living, dying, and seeding again, all at once, across a theater so vast it can barely be imagined. None of this happens quickly. It doesn't need to. The universe has time. It isn't in a rush. It doesn't blink. It doesn't pause. It simply continues, building complexity from simplicity, one fusion reaction at a time. And here you are, a collection of that same star-made matter, resting in the dark, breathing quietly while the cosmos continues its quiet alchemy all around you. Somewhere, right now, a star is dying. Somewhere else, another is being born. And in between, in this sliver of time, you are here, made from the ashes of giants, alive in the pause between explosions, listening, drifting, remembering that even in silence, even in the dark, the universe never stopped creating, and neither did you. Most of what exists can't be seen. You wake up each morning, surrounded by matter, your bed, your room, the air in your lungs, the skin you carry, and all of it feels solid, real, accounted for. And yet, when we step back and measure the universe at scale, when we run the numbers and try to add up everything visible, every planet, star, comet, dust cloud, gas giant, ice crystal, black hole, and lonely photon wandering between galaxies, it still doesn't explain how the cosmos holds itself together. The math doesn't add up. Galaxies spin too fast. Their outer stars should fly off like sparks from a wheel, and yet they don't. They hold together with a kind of quiet defiance, like dancers suspended on invisible strings. The only explanation that fits and fits consistently is that something massive, something utterly silent and unseen is holding them in place. We call it dark matter. It's not dark because it's evil or mysterious or hiding in corners like a villain. It's dark because it doesn't shine, it doesn't reflect, it doesn't glow. Light doesn't bounce off it. It doesn't absorb or emit radiation. It just island present but untouchable, massive but mute, entirely invisible, except for the way it bends everything around it. You've never seen dark matter, but it's there, 5 times more abundant than the ordinary matter that makes up you and me and everything we know. You're floating in it, swimming through it, held together by it, and still, we don't know what it island. It's not made of atoms. It's not like any particle we've isolated in a lab. It might be composed of WIMPs, weakly interacting massive particles, or something even stranger that we haven't named yet. Every experiment that's tried to catch it directly has come up empty. It slips through detectors like smoke through fingers, perfectly transparent to every tool we've built. And yet the evidence for it is overwhelming. When we look at colliding galaxies, we can see the visible matter crashing together, stars ripped apart, gas clouds smashed into chaotic shapes. But the gravitational footprint tells a different story. Something heavier than the visible wreckage keeps drifting through, undisturbed, like a ghost walking through fire. That ghost is dark matter. It's shaped the universe since the beginning. In the early days, when the universe was still hot, dense, and barely cooled from its violent birth, it was dark matter that began to pull things together. While regular matter was too energetic, too scattered, too tangled in light and pressure, the dark matter gathered in clumps. These invisible halos of gravity became scaffolding for the first galaxies. Like invisible nets, they caught gas and stars and stitched them into form. Without it, the universe would still be formless, quiet, yes, but empty. When you look at a map of the large-scale structure of the cosmos, clusters of galaxies strung together in a web-like pattern, vast filaments stretching across unimaginable distances, you're looking at the handwriting of dark matter. You're seeing what gravity traced into the void. You're seeing the bones of the universe, and still, it keeps its distance. You can't bottle it. You can't scoop it from a crater or find it buried beneath ice. It passes through Earth every second, billions of particles brushing your skin, your organs, the deepest stone of the planet. And you don't feel a thing. It doesn't react. It doesn't stop. It doesn't seem to care whether we notice it or not. But we do notice. We see its fingerprints in galactic rotation curves. We see the way its mass lenses light, bending the path of distant stars and galaxies behind it like a magnifying glass. We can measure the mass of a galaxy cluster and compare it to the light it gives off. The difference, always, is dark matter. Every time we look closer, the universe whispers the same message. Most of what matters can't be seen. This truth changes things. It means that reality, as we experience it, is only a fraction of what's really there. It means that even our best telescopes, our most sensitive instruments, are tuned to a sliver of the truth. The rest hums silently in the background, shaping our world without ever showing its face. There's something humbling about that, to know that you're a rare kind of matter, that you, made of atoms, are the minority, that the cosmos runs on rules that weren't written with us in mind. It's like discovering you're a guest at a party much older and stranger than you thought, and the hosts are invisible. And yet, here you are, a mind made of ordinary matter, contemplating the extraordinary, asking questions of the dark, building machines to feel for what eyes can't see, and finding, over and over, that the universe gives answers in the language of shadows. The stars are beautiful. The galaxies are grand. But the silence in between, that's where the real story is written. In the pull of things unseen, in the weight we can't touch, in the darkness that holds everything together. You spend your whole life thinking of reality as singular. One world, one sky, one set of rules. Even when you imagine distant galaxies, strange physics, or the echo of a bang from billions of years ago, you still think of it as this universe, the one we live in, the one where stars are born and die, and whisper their light across time until it reaches your eyes. But what if this wasn't the only one? Not in the poetic sense, not just as metaphor. What if our universe, this vast, ancient, expanding cosmos, was just one ripple in a much larger ocean? The idea sounds like science fiction, and maybe an island, but it's also quietly built into some of the best theories we have, because the mathematics that describe our early universe don't end neatly. They unravel into something stranger, something colder, something much bigger than we're meant to hold in a single mind. It begins with inflation, when that strange moment after the Big Bang, when everything didn't just expand, but inflated faster than light, stretching space itself like warm taffy. This wasn't a slow blooming, it was a violent shudder, a balloon growing so fast that it didn't just get bigger, it created the space it expanded into. But according to some versions of this theory, inflation didn't happen once. It didn't even end. It might still be happening, in places we can't see, and never will. That's eternal inflation. Tiny patches of this inflating space slow down and cool, just like ours did, forming bubbles. Each bubble its own universe, each with its own physics, its own constants, its own story. Maybe some are like ours, with galaxies and gravity and long, slow deaths. Maybe others collapsed instantly, or never cooled at all, or followed rules we can't imagine, where time bends backward or light moves sideways, or stars are made of something we don't have a name for. And inside just one of those bubbles, our stars formed, our galaxies spun, our atoms fused and cooled and combined and gave rise to cells and memories and questions like this one. The kind that keep you up late wondering if your life is a spark in a field of fireflies, or if it's just one echo in a canyon with no walls. The multiverse, if it exists, is not a place we can visit. There's no spaceship fast enough, no telescope sharp enough, no signal strong enough to reach another bubble. They're expanding away too quickly. Their edges are sealed by the speed of space itself. But like dark matter, like the shape of time, we don't always need to see something to know it's there. We can see what ideas make the math work. We can look at the tremble in the early light and ask, could this be the scar of something bigger? Not proof, but possibility. And maybe that's enough. Because even the suggestion that our universe isn't the only one, that there are countless others flickering into being, most never to be known, changes how we look at this one. This fragile patch of space, this warm sliver of time, it makes every coincidence feel more miraculous, every law more precious, every moment more borrowed. You, sitting there in bed, drifting between breath and dream, were sculpted by the odds, born in a bubble that cooled just right, on a planet that formed at the right distance from a star that's burning for just long enough, with neurons that fire in patterns that somehow create not just thought, but wonder. You are not guaranteed. You are rare. Not because the universe cares. It doesn't. Not because it made you special. It didn't. But because even in a reality where everything that can happen does happen, something about this moment, your breath, your story, your night, happened exactly this way, and that makes it sacred. Maybe we'll never know for sure. Maybe there are no other universes. Maybe there are infinite. But either way, you only have this one, this story, this soft orbit of time before sleep, where atoms remember stars and silence feels like gravity. So close your eyes. You're floating in a bubble universe, sealed by the speed of light, cradled by chance, and wrapped in cosmic possibility. And tonight, that's enough. The galaxies don't just drift. They stretch across the universe in long, tangled strands, like tendons in a colossal, ancient body, too large to see at once. From a distance, they look like a nervous system flickering with scattered pulses of light. Not random, not chaotic, structured, and all of it woven into a shape we weren't supposed to understand, yet somehow glimpsed. The name we gave it is the cosmic web. You can think of it like this. Take the night sky and imagine every single point of light, every galaxy, not every star, as a single bead threaded onto an invisible lattice of gravity. Then zoom out, further, even further, past clusters of galaxies, past walls of stars, past even the boundaries of imagination. What emerges is a pattern, a sprawl of filaments, great sweeping rivers of light stitched together by dark matter, like veins carrying the lifeblood of the cosmos. Each filament is made of galaxies, hundreds of thousands of them, stretched along gravity's curve. They didn't end up that way by accident. In the beginning, the universe was mostly smooth, like a just-poured cup of coffee. But there were tiny imperfections, little fluctuations in density, like faint ripples in a calm pond. And gravity, ever the patient sculptor, leaned into those ripples, pulling matter inward, letting the overdense regions swell into walls and letting the underdense regions empty into voids. The result? A structure too vast for the human mind to hold all at once. Our Milky Way is just a bead on one of these threads. It belongs to a group, the local group, a small, quiet collection of galaxies. That group belongs to a larger one, the Virgo supercluster. And that supercluster is part of something even more immense. Laniakea, our galactic home address in a universe that does not send mail. But Laniakea isn't an island. It's a tributary in a galactic river, drawn into a flow towards something enormous, the Shapley supercluster, a gravitational sink that tugs at entire swaths of the universe. We are all moving, not because we're speeding through space, but because the fabric itself is draped into these vast, winding canals of gravity. The space between these filaments is where the quiet lives. The voids, these aren't just patches of empty space. They're massive, yawning bubbles where almost nothing exists. A single galaxy, if any. No bustling clusters, no glittering arms, no dense traffic of stars, just silence and dark. And these voids stretch for hundreds of millions of light years. You could aim a spaceship at one and fly for eternity without seeing anything more complex than a few lonely photons whispering past. And yet, those voids matter, because the emptiness accentuates the structure. Just like the hollows in a spider's web define the strands. The emptier the void, the brighter the wall beside it. The deeper the silence, the more beautiful the sound. Astronomers have mapped this web, not directly, of course. It's too large, too layered. But by surveying the sky, by measuring redshift after redshift, they've drawn the outlines. Point after point, galaxy after galaxy, they built a 3D atlas of the universe. And when the maps came back, when they were stitched together and lit from within, the pattern emerged. It wasn't flat. It wasn't random. It was a web. A lace of light, the nervous system of creation. And like any nervous system, it pulses with information. Galaxies don't just sit still. They move. They fall into one another. Clusters merge and swirl, dancing along gravity's scaffold. Sometimes, entire rivers of galaxies, what astronomers call flows, funnel toward a denser node, pulled in by some great invisible hand. Its movement not just in space, but through time. A kind of gravitational weather, slow and unstoppable. The cosmic web isn't frozen. It's breathing. Even now, it's evolving. Filaments are thickening. Voids are growing. The structures are stretching apart as dark energy pulls on the seams of the universe. Eventually, the web may thin. Galaxies too distant to see. Gravity too weak to bind new clusters. The lights will fade, strand by strand. But for now, for tonight, it glows. And in that glow is a kind of reminder that the universe has a shape, that even across the largest scales there is form, there is tension, There is design, not necessarily purpose, but beauty. And maybe that's enough. When you lie in bed and stare into the ceiling and think about everything you haven't done and everything you'll never know, remember this: you are a spark on a filament, a flicker in the great web of light, not outside of it, part of it, held in place by the same forces that knit galaxies together. You move with the rest of it, slowly, silently, toward some future shape none of us will live to see. But it's still forming, and you were here to notice. There is no center. That's the part that breaks something deep inside the mind. Because everything you've ever known, every room, every city, every life you've passed through, has had one. A heart. A middle. A place where things began, where everything else expanded outward from. But the universe is not built like that. It never was. When the Big Bang happened, it didn't explode like fireworks from a single dot into a larger space. That image, the one we carry from childhood, the one of a glowing ball bursting in a sea of black, is wrong. There was no sea of black, no surrounding silence, no empty space waiting to be filled. There was only the moment itself, and space didn't exist until that moment began to stretch. Space itself was born, expanding. It wasn't a bang in space. It was a bang of space. Imagine a balloon, not the part that floats, the skin. Now imagine dots drawn across that skin, evenly spaced. As you blow air into the balloon, the surface stretches, and every dot moves away from every other. There's no single dot you can point to and say, that's the center. All of them are moving apart. All of them experience every other as receding. That's what the universe is doing. Every galaxy we observe, no matter where we look, is moving away from us. But that doesn't mean we're at the center. If you lived in a galaxy 100 million light years away, you'd see the same thing. Everything would still be drifting apart from you. Not because we're all flying away through space like shrapnel, but because the space between us is stretching. The distances themselves are growing. It's a kind of movement without motion. That's the strange poetry of it. Galaxies aren't racing through the cosmos like runners in a stadium. They're mostly sitting still, held in place by gravity, while the stadium itself swells, the track beneath their feet widening, the lines between them lengthening without effort or force. A kind of universal exhale that hasn't stopped in over 13.8 billion years. And because of this expansion, there is no edge, there is no wall, no outer rim, no last galaxy clinging to the fringe of the void, peering into absolute nothing. Wherever you go, the universe continues. You can travel in any direction, for any amount of time, and you'll never hit the end. The fabric just keeps stretching, like a song that rewrites its own melody as it plays. We like to think of things with edges. It's how we draw maps, how we tell stories. The edge of the world, the edge of the forest, the edge of reason. But the universe resists that. It offers no cliff, no outer crust, no final star to mark the boundary. Just more time, more distance, more galaxies falling away into redshifted silence. And no matter how far you travel, you will always seem to be in the middle. Because from your point of view, everything recedes. Every galaxy drifts outward. Every cluster falls back. It gives the illusion of centrality, a trick of perspective that flatters the observer. But every observer sees the same trick. Every location in the cosmos feels like the origin, like the place where everything began. And that's the secret. There is no privileged place, no cosmic capital, just islands of light floating on a sea of time. Even the term Big Bang can be misleading. It suggests noise, heat, shock waves, but in truth, it wasn't loud. There was no air to carry sound, no outside vantage point to witness the flash. It wasn't a fireball. It was a bloom, a shift from something unknowable into something spacious, expanding, cooling. A process so vast and slow that only now are we starting to see its shape. And yet, here you are, a mind curled in a bed, breathing in the quiet of a dark room, thinking about things no human was ever built to understand, drifting between dreams and stars, between the tick of a clock and the drift of galaxies. Your body is made of particles born in that initial expansion, hydrogen forged in the first minutes, carbon fused in stars, oxygen scattered by supernovae. You are not just in the universe, you are of it, and you are not at the center. But neither is anyone else. There is something freeing in that. It means no one is the axis. No place is more sacred. Every galaxy holds equal weight in the fabric. Every distant star has the same claim to here, even Earth, with its oceans and cities and arguments and loves, is just a point among trillions, a flicker in a web without a hub. And yet that flicker is enough. The universe doesn't need a center to be beautiful. It doesn't need an edge to be complete. It unfolds in every direction, forever. And you, here, now, in the middle of your night, are watching it happen. Not from the center, but from a place just as valid, just as temporary, just as extraordinary. When you look up at the night sky, you're not seeing the present. You're looking into a deep, layered memory, one that belongs to the universe itself. Every star, every faint glimmer, every soft smear of distant light on the ink-black canvas above you is a whisper from the past, some recent, some impossibly old, some older than anything that's ever drawn breath on this planet. The sky isn't just a view, it's a time machine, because light doesn't move instantly. It's fast, unimaginably so, nearly 300 kilometers per second. But even at that speed, the distances are so enormous that light takes time to arrive. When you see the sun, you're not seeing it as it is now. You're seeing it as it was 8 minutes ago. If the sun vanished in an instant, you'd still bask in its glow for a final 8-minute delay. You'd live in the illusion of its presence, while its absence rushed toward you at light speed. And that delay, that cosmic lag, gets more dramatic the farther out you look. The nearest star system, Alpha Centauri, is over 4 light years away. That means its light, the light touching your retinas tonight, began its journey before you finished your last year of school, before your most recent heartbreak, before your dog got old. It's the past, masquerading as the present. Go further, and the illusion deepens. When you gaze at the Orion Nebula, you're looking 300 years into the past. That light left before the first castles rose in Europe, before the ink of early books, before language sounded anything like it does now. What you're seeing is a relic, a fossil of photons. Astronomy is the only science that lets you look back in time without leaving your chair. It's not metaphor. It's not poetry dressed as physics. It's the literal truth. Telescopes are time machines. Point them at a distant galaxy, and you're observing that galaxy not as an island, but as it was millions, even billions, of years ago. The Hubble Space Telescope has shown us galaxies as they were just a few 100 million years after the Big Bang. Not in theory, not as simulation, but in actual ancient light, finally arriving after an unfathomable voyage. It's humbling. You stare into the cosmos and realize you're surrounded by ghosts, the soft afterglow of long-dead stars. Some of the brilliant specks above you tonight may not even exist anymore. Their fires could have gone out centuries ago. Their worlds could have gone cold. But the light they cast while they were alive is still on its way, still streaming through the vacuum, still painting a story across your sky. The night is full of beautiful lies, because what you're seeing is never now. It's always then. The starlight that inspires your wonder is the last trace of something that might have perished long before you were born. It makes the sky less like a ceiling and more like a museum, and light is the artifact. These photons are survivors, carrying tales of fusion and gravity and birth and death. They've crossed gulfs that would shatter any ship, dodged dust clouds and cosmic rays, curved around black holes, and threaded the needle of time itself to find you, to land, quietly, gently, in your eye. Your brain translates them into sparkle and twinkle, but they are messages, old ones, worn but intact, proof that something once burned, somewhere far away, and that it mattered enough to shine. And when you think of it that way, even the darkness takes on new meaning. The black parts of the sky, the spaces between stars, they're not truly empty. They're not even truly dark. Some contain galaxies so distant, their light hasn't reached us yet. Others hold stars too faint for human eyes. Some are voids, yes, but others are simply futures in waiting, their messages still in transit, light that has not yet arrived. Histories not yet uncovered. The sky is still catching up with itself. There's a strange comfort in that even as everything around us seems to rush forward. Deadlines, headlines, sunrises. The universe is still bringing us news from the beginning, that the stars still whisper to us about what came before, that the sky is both archive and stage, preserving stories in waves of light. And you, for all your smallness, are part of it. You are one of the few creatures, maybe the only kind in this corner of the cosmos, who can look up and understand what you're seeing, who can feel the weight of it. The passage of time etched into the sky like soft scars. You're not just watching, you're witnessing. So when you find yourself outside late, or unable to sleep, or just a little too human for the noise of your own mind, look up, not for guidance, but for memory. The sky has always been there, but what it shows you is not where things are, but where they were. A portrait of what once was, a gallery of light, curated by time itself. And tonight, you're not just under it, you're inside it. Everything around you is cold and quiet now. The day's noise has drained from the walls, the light has softened into shadows, and you're wrapped in whatever you use to feel safe. A blanket, a thought, a silence. But even here, even now, something ancient is humming, not loudly, not urgently, just a whisper. It's everywhere. In the space between your fingers, in the space between galaxies. It's not a sound, but it's something like music, a note held across billions of years. A song written at the beginning of time and still playing, so softly that most of us will live our entire lives without ever knowing it's there. But at Island, the cosmic microwave background, that's its name, is the oldest light in the universe. Not the brightest, not the sharpest, but the first. A glow left behind by the Big Bang, still echoing through every corner of space, like a campfire long extinguished but somehow still warming the rocks. If you could see in microwaves, the entire sky would shimmer with this ghost light. It's not coming from one direction. It's not a beam or a flash. It's a presence, a hush, and it's still warming us, just barely. The temperature of the cosmic microwave background is 2.7 Kelvin. That's 2.7 degrees above absolute zero. The point where all motion stops, where even atoms freeze in place. So this isn't a fire, it's a breath, a memory, a nearly imperceptible warmth that reminds us the universe used to be something else. Used to be hot and close. Once upon a time. And yes, we're allowed to use that phrase here. Everything was together. All the matter, all the energy, all the rules and randomness that would one day become stars and supernovae in you, sitting there now. There was no night and day, no left or right, just one place, one temperature, one thing. And then it expanded, not exploded. That's the wrong image. The Big Bang wasn't a blast in the middle of nothing. It was an expansion of everything, everywhere, all at once. There was no edge to the explosion, because there was no outside to the universe. It stretched like rising dough, like a breath being exhaled for the first time. As space expanded, it cooled. That heat, that unbearable, brilliant heat of creation, began to thin out, like steam from a kettle left on the counter. Eventually, it dimmed enough to become light. Not visible light, not yet, but light all the same, free to travel, to move, to stretch with space itself. That's what the cosmic microwave background island. It's that first light, not a spark, a glow, released when the universe became transparent enough to let photons roam. Before that moment, the universe was like a fogged window, too dense, too hot. Photons couldn't get anywhere without slamming into particles. But around 380, 0 years after the Big Bang, everything had cooled just enough that atoms could form. The fog lifted. Light escaped, and it's been moving ever since. That light has redshifted, stretched, as the universe has expanded. Originally, it would have been more like a warm orange glow if you had eyes to see it. But space keeps growing, and as it does, it pulls the wavelength of that light longer and longer. Until now, billions of years later, it's become microwaves. That's what makes it so beautiful. It's not just light from the past. It is the past, unchanged, undisturbed, still arriving, still wrapping itself around planets and satellite dishes and every empty bit of sky we mistake for silence. You're bathing in it right now. It's washing over your body, gently, quietly, at all times. It doesn't carry heat in any way you'd notice, not like the sun on your skin or the warmth of a hand in yours, but it's there, a cradle temperature, the base note of the universe. Astronomers discovered it in the 1960s, almost by accident. Two men, Arno Penzias and Robert Wilson. They were working with a radio antenna when they picked up a background noise that wouldn't go away. They checked the electronics, cleaned out bird droppings, adjusted everything they could, but the hum stayed. Eventually, they realized what it was. They had stumbled into the leftover light of creation. It was a discovery that reshaped cosmology, proof that the universe had a beginning, that the Big Bang wasn't just a theory, but something you could detect, something still echoing through the cold. Scientists all over the world tuned in, not just to confirm the signal, but to map it, to chart the faint ripples and fluctuations in that glow. Because within those ripples are the seeds of everything: galaxies, stars, planets, life. It's hard to imagine that everything you've ever known began as a wrinkle in warmth. But it did. There's a kind of reverence in that knowledge, that the universe carries its memory forward, not in journals or monuments, but in temperature, in faint, humming radiation, that the past doesn't vanish. It diffuses, it cools, it becomes background, but it stays. So next time you're outside and the world feels still, remember, there's something older than time itself, gently falling over your skin. It doesn't care who you are. It doesn't require belief. It doesn't knock or announce its presence. It just exists, quiet and ancient and everywhere. At the edge of imagination, there is a silence so vast it has no name. Not the silence of a room at night, not even the hush of deep space between stars, but something deeper. A stillness that isn't just quiet, but empty. A time when the last light flickers out and the last voice of matter grows too tired to speak. It's not now, not soon, but it may be the destiny of everything we know. And it begins not with an explosion, but with a slow exhale that never draws breath again. The heat death of the universe. It sounds dramatic, like something sudden, like fire or fury. But in truth, it's more like forgetting, a gentle fading stretched across incomprehensible time. You won't feel it. No one will. Because by the time it arrives, there may be no one left to feel anything at all. Right now, the universe is alive with motion. Stars burn, galaxies spin, planets swing in their orbits like quiet pendulums. There are places where light is born every second, where gravity shapes entire systems from dust, where fusion hums like a steady heartbeat. It's warm, in a cosmic sense, structured, full of usable energy. But energy doesn't stay usable forever. That's what Entropy Island. Not destruction, just dispersal. A slow march from order to disorder, from difference to uniformity. Every time a star shines, it bleeds heat into the void. Every time something happens, anything, from the collision of galaxies to the movement of an atom, the universe loses a tiny bit of its potential to do more. It's like pouring hot tea into an infinite bathtub of cold water. At first, the heat spreads, but over time, it dilutes, becomes less noticeable, less useful, until all that's left is tepid sameness. In the far, far future, we're talking trillions of years from now, and stars will start to go out. Not just the bright young ones, but the long-burning red dwarfs that have been quietly holding on. When they finally dim, there won't be any new stars to replace them. The gas clouds that form stars will be gone, used up or too diffuse to ignite. Galaxies will empty. Their cores will go dark. The remaining objects, white dwarfs, neutron stars, black holes, will drift like forgotten thoughts through a growing cold. And even the black holes won't last forever. They too radiate away energy. It's slow. Unbelievably slow, but given enough time, even the deepest well of gravity evaporates into nothing. That's the destination, if the universe continues expanding forever. A vast expanse of thin, cold darkness, dotted sparsely with dimming remnants, until even those are gone. No heat, no light, no structure, just particles stretched so far apart they'll never meet again. A cosmos, not exploding, but extinguishing. And yet, strangely, it doesn't feel like a tragedy. Not in the way we usually think of endings. Because this isn't a story being cut short. It's one being told to its very last page. A novel that took trillions upon trillions of years to write. Every chapter sprawling with stars and questions and wonders. And this final chapter, this quiet one, is simply the last echo. What's astonishing is how much beauty comes before it. If the heat death lies ahead, it also means everything we are is part of the fleeting warmth. We live in a golden age of contrast, where cold and hot, light and dark, gravity and motion all dance together in delicate balance. We are part of the brief moment where the universe still makes stars, still creates complexity, still dreams of life. And it's not set in stone. Heat death is one possibility, based on what we know about physics right now. But the future of the cosmos depends on things we're still learning. Maybe dark energy changes over time. Maybe the universe curves back on itself. Maybe there are other laws hidden beneath what we think are certainties. The future may be long, but it is not fully written. We are not powerless in the face of it, because our part in this timeline is not passive. We observe, we build, we try. Every telescope we launch, every equation we solve, every story we tell, it's all a kind of resistance. A refusal to let the silence have the last word. And even if the universe does cool into stillness, it will carry the memory of heat, of structure, of those who wondered. We are entropy's temporary defiance. So when you lie in bed tonight and imagine the end of everything, don't picture it as a doom. Picture it as distance, a place so far away that even your longest thoughts won't reach it. And between now and then is everything that matters. Every burst of starlight, every planet spinning like a secret, every moment someone looks up and asks, quietly, what happens next? Because the answer might be silence. But tonight, it's still a question. Close your eyes. Let everything soften now. The edges of the day, the breath in your chest, the thoughts still pacing the corridors of your mind. Let them settle, one by one, like dust on a quiet bookshelf. There's nothing left to do, nowhere you need to be. You've made it to the end, not just of the day, not just of this quiet cosmic story, but to a moment that doesn't ask anything from you at all, except to listen and to drift. Tonight, the universe keeps moving without you. Galaxies keep expanding. Stars are being born in nebulae light years away. Somewhere, a comet is sailing silently through a solar system it will never belong to. And black holes, those ancient, invisible mouths, continue to spin patiently, undisturbed. The cosmos hums on. And here you are, a body tucked in soft sheets, a heartbeat that's been echoing since before you were born. You, of all things, are the universe made curious, not a visitor, not a separate witness, but a continuation. You are not under the stars. You are of them, your skin, your breath, your thoughts, all made from atoms that were forged in the bellies of stars long dead. The calcium in your teeth, the iron in your blood, the carbon that holds you together, it was all born in fire, all scattered in explosions, all gathered into you, improbably, over billions of years. You are not an afterthought of the universe. You are its ongoing experiment. The cosmos doesn't know it exists, not unless it's thinking through you, not unless it has neurons and language and wonder. And tonight, as your mind gently fades into rest, you are fulfilling one of the rarest roles that any particle has ever been asked to play. You are the universe, contemplating itself. Think of the odds, the near impossibility of it all. If the laws of physics had been different by a fraction, stars might not have formed, galaxies might not have spun, chemistry might never have developed into biology, and life may never have blinked open a single eye. And yet, it did. Somehow, in at least one small corner of the dark, something began to ask questions. To dream, to laugh, to fear death, to tell stories, to want to be held. You are that miracle. You are a moment of organized stardust, wrapped in memory and thought and skin. And while you might feel small, especially when staring into a night sky that stretches past imagination, you are also rare. Not because you're the center of anything, but because you are a fleeting glimpse of everything, all at once. A temporary arrangement of matter that knows how to care, to long, to listen, and that's enough. You don't need to understand every detail. You don't have to finish every book or hold on to every truth. The universe doesn't need you to figure it out tonight. It's patient. It has time. What it offers instead is presence, a silence that doesn't judge you, a darkness that isn't empty, just resting. So let go now. Let the gentle gravity of sleep pull you inward. Let your breath fall into rhythm with the slow expansion of the cosmos. Nothing urgent remains. Just you, floating in the same space where galaxies bloom, where time bends, where light takes billions of years to cross the void, just so you might glimpse it and feel something. You are not the center of the universe, but you are something better, a witness to its beauty. And when you wake tomorrow, the stars will still be spinning. The earth will still be moving through the deep, slow dance of gravity and chance. You'll carry a little more of that mystery with you, tucked behind your eyes, woven into your bones, and whispered through your dreams. But for now, the universe is quiet, and you, miracle, accident, observer, you get to fall asleep in its arms.